Hey everyone, Linus here. Today we're diving into the fascinating world of emulation. Ever wanted to run a different operating system or even play retro games on your computer? That's where emulation comes in. Essentially, we're tricking our computer into thinking it's a completely different system. We'll be focusing on the x86 architecture, the powerhouse behind most personal computers. Get ready to unlock a whole new level of computing. Emulation allows us to explore the history of computing, test software in controlled environments, and even preserve older systems. Imagine running Windows 95 on your brand new gaming rig just for kicks. By building an emulator, we get to peek under the hood and understand how computers really work at a fundamental level. This isn't just about nostalgia though. Emulation has real-world applications in software development, security research, and even game preservation. By understanding how to emulate a system, you gain valuable skills that can translate to various tech fields. So buckle up, grab your digital toolset, and let's build something awesome together. Today's mission, should you choose to accept it, is to build an x86 emulator from the ground up. That's right. We're talking about writing the code that will trick your computer into becoming another computer. It might sound daunting, but trust me, it's an incredibly rewarding journey. We'll be using a fantastic framework called Archfire to help us along the way. Our goal is to create an emulator that can run any x86 BIOS and software. Think about that for a second. We're talking about running everything from old-school DOS games to maybe even a virtualized version of Windows XP, all within our own custom-built emulator. This is the kind of project that will push your programming skills to the limit and give you a deep understanding of how computers work at their core. We'll be diving deep into the world of virtual CPUs, memory management, and input-output handling. Don't worry if those terms sound intimidating right now. We'll break it all down into manageable chunks. By the end of this journey, you'll be able to impress your friends, and maybe even potential employers, with your newfound emulation expertise. Before we fire up our code editors, let's lay out the essential components of our x86 emulator: the virtual CPU, memory management, input-output, I/O handling, and BIOS software compatibility. Think of these as the fundamental building blocks of our virtual machine. The virtual CPU is the brains of the operation, responsible for executing instructions from the software we want to run. It's like the CPU in your physical computer, but instead of being a physical chip, we're going to build it using code. Memory management handles the allocation and access of virtual memory, the space where our emulated programs and data reside. Input-output handling allows our virtual machine to interact with the outside world. This means handling things like keyboard inputs, mouse clicks, and even displaying graphics on the screen. Finally, BIOS and software compatibility ensure that our emulator can actually run the software we throw at it. Each of these components plays a crucial role in creating a seamless emulation experience. We'll be exploring each of them in detail in the upcoming sections, so get ready to dive deep into the exciting world of emulator development. The heart of any emulator is its virtual CPU, vCPU. This is where the magic happens, where lines of code transform into simulated hardware. Our task is to create a software representation of a physical x86 CPU, capable of understanding and executing its instructions. We begin by defining the vCPU's state, which includes registers, small storage areas within the CPU, and flags that indicate the current status of the processor. Then we meticulously implement instructions from the x86 instruction set. These instructions are the fundamental commands that the CPU understands, ranging from simple arithmetic operations to complex memory manipulations. For each instruction, we write code that fetches the instruction from memory, decodes its meaning, retrieves any necessary operands, data the instruction operates on, performs the operation, and stores the result. This process is known as the fetch, decode, execute cycle, the heartbeat of any CPU. Building the vCPU is a meticulous process requiring a deep understanding of the x86 architecture, but fear not, with Archfire's robust framework and clear documentation, you'll have all the tools you need to craft a powerful and efficient virtual brain for your emulator. Section 5. Organizing the data memory management. No computer, real or virtual, can function without memory. This is where our programs and data reside while being executed. Our emulator needs a way to manage this memory effectively, ensuring that our virtualized software has access to the resources it needs. We achieve this through a component called the Memory Management Unit, or MMU. This module is responsible for mapping virtual memory addresses used by the software to physical addresses in our computer's RAM. This mapping process can be simple or complex, depending on the level of accuracy we aim for. A key aspect of memory management is handling memory protection. Just like a real operating system, our emulator needs to prevent programs from accessing memory locations that don't belong to them, ensuring stability and security within our virtual environment. We'll also implement techniques like paging and segmentation, which allow us to manage larger memory spaces efficiently. By carefully designing our MMU, we create a robust and reliable foundation for our virtual machine to store and access data. Section 6. Talking to the outside world I/O handling. Our emulator wouldn't be very useful if it existed in complete isolation. We need a way for it to interact with the outside world, receiving input from the user and displaying the results of its computations. This is where input-output, or I/O handling, comes in. We'll create virtual representations of common I/O devices like the keyboard, mouse, and display. When the emulated software wants to read a key press, it interacts with our virtual keyboard, which then relays that information to our actual keyboard driver. Similarly, when the software wants to display something on the screen, it interacts with our virtual display, which then updates the actual screen. This process involves creating virtual device drivers. These drivers act as intermediaries between the emulated software and the actual hardware on our host machine. This allows the emulated software to remain blissfully unaware that it's not actually interacting with real hardware. I/O handling can be a complex topic, as it often involves dealing with the intricacies of different operating systems and hardware. However, with Archfire's intuitive API and helpful examples, you'll be able to connect your emulator to the outside world with ease. Section 7. Running the show, BIOS and software compatibility. We've built the virtual CPU, managed the memory, and even connected our emulator to the outside world. Now comes the exciting part, ensuring that our emulator can actually run the software we're interested in. This means tackling BIOS and software compatibility. The BIOS, or Basic Input-Output System, is a small program that runs when the computer boots up. It initializes hardware, performs system checks, and then loads the operating system. To achieve a high level of compatibility, we might need to emulate a specific BIOS version. Software compatibility involves ensuring that the programs we want to run can interact correctly with our emulated environment. This might involve handling different operating system versions, supporting various hardware configurations, and even emulating specific quirks of real hardware. Achieving perfect compatibility is a monumental task, often requiring ongoing development and refinement. However, by focusing on common BIOS versions and popular software, we can create an emulator capable of running a wide range of programs and games. Section 8. Squashing bugs, debugging your emulator. Building an emulator is like constructing a complex machine. There are bound to be a few hiccups along the way. That's where debugging comes in. Debugging is the process of identifying and fixing errors in our code, and it's an essential skill for any emulator developer. Fortunately, Archfire comes equipped with powerful debugging tools that make our lives much easier. We can set breakpoints in our code, which pause execution at specific points, allowing us to inspect the state of our virtual machine. We can step through our code line by line, observing how each instruction affects the vCPU, memory, and I/O devices. Archfire also provides logging capabilities, allowing us to record events and data during the emulation process. This log can be invaluable for tracking down elusive bugs and understanding the inner workings of our emulator. Debugging might seem daunting at first, but with the right tools and a bit of patience, you'll become a master bug exterminator in no time. Section 9. Learn as you build comprehensive documentation. We believe that learning by doing is the best way to master any skill, especially something as intricate as emulator development. That's why we've created comprehensive documentation for Archfire designed to guide you through every step of the process. Our documentation covers everything from the basics of emulation to advanced topics like virtual memory management and I/O virtualization. We provide clear explanations, detailed code examples, and helpful diagrams to ensure that you grasp every concept. Whether you're a seasoned programmer or just starting out, our documentation will be your trusty companion throughout your emulation journey. We also encourage you to join our vibrant community of emulator enthusiasts. Our forums are a great place to ask questions, share your creations, and connect with fellow developers. With our comprehensive documentation and supportive community, you'll never feel lost on your path to building an amazing x86 emulator. Section 10. The power of emulation, benefits, and beyond. Congratulations! You've built your very own x86 emulator from scratch. It's time to step back and appreciate the incredible power and versatility of what you've created. Emulators aren't just cool projects, they offer a wide range of practical benefits and open doors to endless possibilities. With your emulator, you can now run older software that might not be compatible with modern operating systems. Imagine revisiting classic games from your childhood or running legacy software that's critical for your work. Emulators also provide a safe and isolated environment for testing software. You can experiment with different configurations and even intentionally crash programs without fear of harming your actual computer. Beyond these practical applications, building an emulator is an incredibly rewarding learning experience. You've gained a deep understanding of computer architecture, operating systems, and low-level programming concepts. These skills are highly sought after in the tech industry and can open doors to exciting career opportunities. Section 11, your emulation journey starts now. So there you have it. We've embarked on a journey into the world of emulation, exploring the intricacies of building an x86 emulator from the ground up. We've covered the core components, delved into technical details, and highlighted the immense satisfaction and practical benefits that come with mastering this fascinating field. But this is just the beginning. The world of emulation is vast and ever-evolving. There are countless avenues to explore, from enhancing your emulator with new features to tackling different architectures and pushing the boundaries of what's possible. So, fire up Archifier, start coding, and let your emulation journey begin. Your adventure awaits.